All right, in this video, we are going to use the AC method to factor this trinomial. Okay, so um, looking at what we've got, right, we have this trinomial. The first step in factoring is always to remove the greatest common factor, right? And so looking at the greatest common factor, 2, right, if I look at 10 and 14, I know they're both even, so a 2 would go into those evenly, but 2 doesn't go into 39, right? And then for 10, the only other thing as factor it has would be a 5, but 5 definitely doesn't go in here into either of these two. And 10, right, doesn't go into any of these either. So number wise, the largest integer or whole number, right, that goes into 10, 39, and 14 is 1. So for factoring, that's just not super helpful. And they don't have, this term has two x's, factors of x. This has one factor of x, and this one doesn't have any. So they don't even have any x's, all have at least one x in common. So the greatest common factor is 1, so, but it always kind of pays to check that first. All right, so this is one of the types of polynomials, trinomial, that we would use the AC method. And here A is 10, right? And C is 14. So we would be looking for two numbers that multiply to give us 140, right? 140 because that's 10, the term with the x squared, times the constant, which is 14. So 10 times 14 is 140. And we need that those two numbers multiply to give us 39, or add up to give us 39. Okay, so that is quite a big thing to try, right? And so what we're going to do is kind of just run through the possibilities on the calculator. So with 140, right, it would be 1 times 140. That there's no way, right, that 140 and 1 are either going to add up or subtract to give anything close to 39. All right, so we would keep going. What about 2? It's 2 and 70. All right, 3 doesn't go in evenly. 4 goes in, so that's 4 and 35. And I'm writing these down, right? And I can see, hey, wait a second, that one looks really good, right? 70 and 2 is not, right? Because 70 plus 2 would be 72. 70 minus 2 would be 68. But I can see right here 35 and 4, right? If I add those, for sure, that gives me 39. So it looks like those are my two right there. All right. And the signs aren't a big deal here either because both these numbers are positive, right? So just double checking myself, right? 4 times 35, that gives me 140, and 4 plus 35, that gives me 39. So right there, those are the two numbers that I'm looking for. Okay. All right, so with the AC method, what you want to do is to take that middle term and split it up using those two numbers. So I'm going to write this as 4x plus 35x plus 14. All right, so again, that steps looks weird if you're not used to it, but because normally you're going backwards, right? Normally you're simplifying like terms. Here I'm kind of creating some like terms, right, for the purpose of this method. So again, you can double check yourself here. If I simplify this, do I get this exactly? And I absolutely do, right? Because 4x plus 35x gives me 39x. So this expression and this expression here are exactly equal. All right, and so remember, the reason why you split these up is so that you can try factoring by grouping. All right, so I look at these two terms and ask myself, hey, what do these two terms have in common? And that would be a 2x, right? So 10 divided by 2 would give me a 5. If I factor an x out of x squared, that will leave me with an x. And then 4 divided by 2 would give me a 2. And then this x is factored out. All right, then I look at the second two terms and see what they have in common, right? I have a 35 and a 14, so 7, right, would be a common factor for those two terms. All right, 35 divided by 7 would be 5x, and that's looking good, right? Because 5x here. 14 divided by 7 would be 2, so that's plus 2. And that's exactly what I want, right? For this AC method to work, I need to have these match up exactly. And on these problems, in the AC method, if you can find these two numbers, it will work out, okay? And also it doesn't matter if you put 35x and 4x, that's going to work out fine as well. You'll have the factors backwards, but that's okay, because remember, it doesn't matter the order in which you multiply two real numbers, right? It's commutative, so meaning that, say like 3 times 5 is the same as 5 times 3, so the order doesn't matter. All right, the next step, right, is to look at these two terms as two big terms, right? And the thing is that they have now a common factor, and that common factor is a 5x plus 2. So you would pull it out, right? Just like you can pull out any common factor. And then what you would do is to see what would I have left after that common factor is pulled out. So looking at this first big term, I have this 5x plus 2 has now been pulled out in front, and that would leave me just with this 2x right here. And I have this plus, right, that came from here. And then out of this big term, if I pulled that 5x plus 2 out, I'd have this 7 left right here. Okay. All right, and that is it. This now is completely factored. These two terms, right, can't be factored any further using the techniques so far that we've talked about. Okay.